These are the solutions for the third practice quiz for quiz 6. So on the first three, you are writing down the number of solutions. Very quick, very simple. On 4, 5, and 6, you are graphing, and you're using only graphing in tables to do this. So on number 4, you're going to see that at 4, 6, and 1, 3 are the two solutions. And then 1, 3. And then what we'll do is we'll get these on the table to get some points for the quadratic. But the whole idea on this exercise is we want you to know how to spot things using a table. Okay, so you see at 1 we have 3, and then at 4 there's 6. So for the quadratic, I see at 2, 2, zoom in a little bit, is the vertex because of that pattern above and below again. And then you know these points are on the quadratic, so just count and use symmetry to get these. Number 5, -1, 6 is the lone point. And we will, so that y equals 6 is the horizontal line. You can have vertical lines also, but I chose horizontal lines so that we can put them on the calculator. So x squared plus 2x plus 7, and then 6. Oops, I don't make that same mistake I did last time. So you see at -1, 6 is that point of intersection. It's also the vertex. And 0, 7 is so the quadratic will open like this. Okay, number 6, there is no points of intersection, but we need to do the graphs. We need to do the graphs. So I just substituted a couple points really quick for the line, 0, 1, and -1, 0. Should be able to mentally graph a line if it's a simple situation. So x squared minus 3x plus 9. And then we'll do the x plus 1. You should probably look at the graphs of these also. Oh, we missed the vertex. It's 0.5. It's my wonderful advertisement again. I'm sorry, it's 1.5. So if we start at 1.5, you can see it. Yeah, you could calculate it too, but I figured it out from the, so 1.5, 6.75. Right there, and then just pick a couple other nice points, which I'm going to just go back to where we were. This is probably the better way. 0, 9. And then you can just, so 1.5 that way. So yeah, sometimes the vertex is not a nice value. Oops, it was off the screen there. Get rid of the scoopy thing. I haven't figured it out. I probably never will. But I need this visualizer, this IPVO visualizer to do my online lessons. Okay, second page. Again, I need to see the simplified quadratic as you do this. So you're going to set them equal to each other and take everything to one side. So -x squared minus 3x plus 54. And you're going to get -9 and 6. So that's the first part of the coordinates. And then just go up here. So -47, -27 minus 20. And then 18 minus 20, -2. This next one's going to give you an empty set, but again, I need to see the simplified quadratic. That's where your points are going to come from, because I know that you know how to use technology to find these. So negative x squared minus 6x minus 16 is the simplified quadratic. Just want to double check my work really quick that indeed that is right. Indeed it is. And then number 9. So you see y equals 1, that means y equals 1 in the solution. They're already giving you the answer. So all you got to do is substitute it in up here. Yeah, you do substitute it, but okay, I was not thinking. We do the same thing. 1, you set them equal to each other. The longer I do these bulk online lessons, the worse my mind gets. Try to go too fast. And so you will get 2 twice when you do this. And so x is 2. And y was already 1. We didn't even have to really substitute it in. Okay, number 10. Again, I need to see the simplified quadratic. These are going to get set equal to each other. There could be 1, none, or 2 solutions. In x plus 45. So you're going to get 2 this time, 5 and 9. So 5 days and 9 days. So x is the number of days. And then you have to substitute in to get y. Try not to write them as a coordinate because we're breaking the coordinate apart to answer. So 28 days, or 28 people, excuse me, after 5 days, and then 9 would be 36 and 8, 44. You just substitute in back to the linear one. So there's 2 that work there. And then your rigorous spiral section. Toughest spiral section of the year. Now this is going to open down. A is -1, B is 6, C is 0. And 3, 9 will be your vertex. And you can get this by, again, looking on your table. And 3, 9, 1, 2. I'm going to make them to where you can use your table for most of this. If you didn't know how to, you got to do the -b over 2a. That's what you would do. And then to get 9, you just go to your table and it would do that. So maximum at y equals 9, x equals 3, y-intercepts are 0 and 6. This is where y equals 0 on your table. And where x equals 0 on your table, you get 0. Okay, so when you have an x-intercept of 0, it's also a y-intercept. Domain is going to be all reals again. Remember, we're trying to put the box around so we can get the top on. So that means the right-hand side of this inequality here is 9. So you have to think about, these are the numbers that are the sides of the box. Well, we only got a top. So this is bottom and top. This is left and right. Because the range is how the y values fluctuate. The domain's how the x values. So all we got is a top. So only 9. So if you had a box around the whole thing, you would have numbers in all 4 of those places. You can't get a box on the left and right because it keeps getting wider and wider and wider. You can't put a box on the bottom because it keeps going down forever. Okay, so your intervals of increasing, you do a less than and greater than. the x value of the vertex. Then you trace the graph left to right. So this is increasing, less than 3, and decreasing is greater than 3. You got to trace the graph left to right. Don't worry about those arrows. Those arrows are for the end problem. You trace it left to right. So negative infinity in both of these. On 12, this is going to open up, and your vertex is 4, negative 4. You can tell that right from the x minus h plus k. Remember that the x appears opposite. So 4, negative 4. And then also you can get that 2 and 6 are the x-intercepts on this. So here I made it nice for you. It's not always going to be, and that's when you have to use your... There's a zero finder, which I'll probably show you later, that you can also use when you're looking at the graph. That's very convenient also. So there's going to be a minimum value at negative 4. Axis symmetry, x equals 4. That's the x value of the vertex. 2 and 6, you can get this off your table, or the quadratic formula, or completing the square. Actually, completing the square is, you just set that equal to 0. Yeah, that's good. Forget I said that. Y-intercept, so this is when x equals 0. And on the table, you would get 12. Or just put in 0 for x. So negative 4 squared, 16. 16 minus 4 is 12. Domain, all reals. Range, we've got the bottom side of the box. So that's through negative 4. So that's going to go on the left side. That's the bottom. Bottom top, left right. Okay, and your intervals, so we're going to go x is less than 4, x is greater than 4. So you grab the x value of the vertex right there. So less than 4 is decreasing, greater than 4 is increasing. And then ends of your graph are going up. End behavior really means as x gets infinitely large, what is y doing? So if we go way out here, left and right, the graph will be way up there and getting wider and wider as you go way out. Okay, so that's the third practice quiz for quiz 6.